welcome to the chapter 2 of the series Computer Networks. We will discuss the overview of OSI model. What is OSI model? OSI stands for Open System Interconnection. It was released by the International Organization for Standardization in 1984. It is a reference model that describes how information from an application in one computer moves through a physical medium to the application in another computer. OSI isn't a physical model though, rather, it's a set of guidelines that application developers can use to create and implement applications that runs on a network. OSI model is a layered framework and consists of 7 layers, and each layer performs a particular network function. Let's talk about the 7 layers of OSI model. We'll describe OSI layers top down from the application layer that directly serves the end user down to the physical layer. Application layer is used by the end user software such as web browsers or email clients. It provides human-machine interaction by providing protocols that allow software to send and receive information and present meaningful data to the user. Presentation layer defines how two devices should encode, encrypt, and compress data so it is received correctly on the other end. The session layer creates communication channels called sessions between devices. It is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and closing them when the communication ends. Transport layer takes data transferred in the session layer and breaks it into segments on the transmitting end. It is responsible for reassembling the segments on the receiving end, turning it back into the data that can be used by the session layer. Network layer is responsible for routing packets by discovering the best path across a physical network. The network layer uses network addresses to route packets to a destination node. Data link layer breaks up packets into frames and sends them from source to destination. This layer is made up of 2 parts. Logical link control, which identifies network protocols, performs error checking, and synchronizes frames. And secondly, media access control, which uses MAC addresses to connect devices and define permission to transmit and receive data. Physical layer is responsible for the physical cable or wireless connection between network node. It is responsible for the transmission of the raw data, which is simply a series of zeros and ones, while taking care of the bit control. Transport layer is also known as the heart of OSI. The bottom 3 layers are the hardware layers, while the top 3 layers are called as the software layers. Now let's have a look at how data flows through the OSI layers. Remember, if you are a sender, data flows from the application layer to the physical layer. Suppose user or sender uses an application, say Google Chrome, to write an email message to communicate with the receiver. This data flows through the 7 layers. Respective layer headers are then attached to this data at each layer. The application layer places a header field that encapsulates information such as screen size and fonts and passes the data to the presentation layer. The presentation layer places layer 6 header information so that receiver understands it. It acts as a data translator. Data encryption and character set conversion such as ASCII are usually associated with this layer. The presentation layer will then pass on the information to the session layer. Session layer follows the same process by adding layer 5 header information such as information that the session layer will manage the data flow and passes this data to the transport layer. Transport layer breaks down the data and places layer 4 header such as an acknowledgement that the segment was received in the header and passes it onto the network layer. The network layer places layer 3 header information such as the source and destination address, as the network layer can determine the best delivery path for the packets and passes this data to the data link layer. The data link layer places layer 2 header and trailer information such as frame check sequences to ensure that the information is not corrupt and passes this to the physical layer for the transmission. All layer add headers, but the data link layer adds both header and trailer. Trailer is for the error detection. The bit is then transmitted as ones and zeros on the physical layer and will ensure the end user data is assembled in the correct order as it was sent. On the receiver side, data flows from the physical layer to the application layer. Respective layer headers are removed at each layer to get the original message. The receiver collects the raw bits from the physical wire and passes them up to the data link layer. The data link layer removes the headers and trailers and passes the remaining information to the network layer, and so forth until data is received by the application layer. Eventually, receiver will receive an email notification displaying a message to indicate that a new email message has been received. This is it on the data flow through OSI. Stay tuned for more detailed videos.